So hello everyone, in the last session we have seen about the magnetic flux. Now we are going to start a new thing, that is from where the magnetic flux is changes into a EMF. So let us start. For that we have to first discuss about the history. That is, what is the history that is going on. Okay, so let us start discussion about the history. So basically what the scientist has seen from the from like what like how they have discovered the magnetic flux, what they have observed, what is the observation they have did, and from there the magnetic flux they go to the EMF. Basically they have performed a experiment, they have performed lot of experiment. So experimental study. Okay, but I will tell you only those thing which is important for you. Experimental study. Okay, because there lot of study has been done. Okay, this is not a result of single study. First what they have did, they have taken a magnetic field. Okay, they have taken a magnetic field, correct? They have taken a magnetic field like this, and then they have taken a some closed surface, and what they have did, they have changed the magnetic field with a time. The magnetic field is varying here, it is varying. Okay, and it is varying. What they have seen, when my magnetic field B is constant, there is no current in the loop. I is 0, there is no current is there. But when the magnetic field is variable, then sorry, when it is constant the I is equal to 0. When it is not constant, then the I is not equal to 0, means there is a some current is there, some current is there. It can be in any direction like this or this, is doesn't matter, but there is a some current is not equal to 0 here. That is a thing which we have seen. Okay, so if this that is a first observation they have seen, कि whenever there is a change in the magnetic field, there is a change, there will be the current. So what they have observed from there, from this experiment, when he changes, I induced, that is called an induced current. Okay, I induced or induced current. Okay, and if there is a current, then that current will come only from the where, it will come from the voltage. So this current is due to EMF, correct? Due to some EMF. So that is called as a induced EMF. That EMF is called as a induced EMF. EMF means nothing but a potential, due to some potential. That is called as a induced EMF. Okay, so that is the first experiment. This is the first part. Okay, this is the first experiment they have did. Now after that they went for the second experiment. What is the second experiment they have did? In the second experiment they have taken the same thing, they have taken a same thing, same everything is same. Okay, they have taken a same, everything is same, there is no changes there. Okay, in the second experiment they have taken this. Now what they have did, they keep B is equal to constant. The B is constant here, and what they have did, suppose this is my radius R na, so R is variable, means R is changing. So R is changing, R is variable, means what is changing? Area is changing. Area is changing, correct? And if area is changing, if you tell me, if suppose the area is changing, then what is going to be happen? Then also we have seen that current in this case is also not equal to 0. There is a current is there, current is there. We have seen the current induces. Means in this case also we have a, we can say we have an induced EMF. We have an induced EMF. Okay, we have an induced EMF. Okay, that is the second thing we have seen. Then after that we go for the third observation. Okay, In third observation, what they have did, they have taken the magnetic field and what we have did, we have start rotating about this axis. We start rotating this. Okay, try to understand, we are rotating like this. So what is happening? The theta is changing. Theta is changing. That is, this means that is angle between area vector and B is changing. So when this thing is changes, then again we have seen I is not equal to 0, that is induced EMF is there. There is a induced EMF. There is a induced EMF. So that is a third observation they have did. So by doing, just note down this observation first. So by doing these observation, what they have understand? They have understand that whenever we are changing the magnetic field or area or a theta, that is the angle between the magnetic field or the angle between the magnetic field or a area, we are changing what? Finally, what we are changing? Whenever we are changing any one of the three quantities, if you remember, I told you that is magnetic flux is what? Magnetic flux is nothing but BA cos theta, correct? If we are changing B or either A or theta or any one of these three combination, what is changes? Phi changes. So after all this three, after all these three things, three observation, the phi changes. So EMF induced. So conclusion is what? Conclusion, we have given that change in magnetic flux, change in phi b cause induced EMF. That is a conclusion we have obtained. Whenever there is a change in magnetic flux, there will be a EMF is induced. Whenever there is a change in a magnetic flux, then the EMF will be induced, and that is a conclusion we have drawn from this experiment. And by the Faradays, and now we have a two calculations are there. If you see, first is the calculation of a magnitude of that current, or you can say of that voltage. Okay, that is the first thing. Second thing is the calculation of the direction of the current. Okay, so there are two calculations are there for us. Two calculations. What are the two calculations? Two calculations. First is the magnitude of current. Magnitude of I. And how to find this? For that we have a Faraday's law. Faraday's law. And second is the direction of I. For that we have a Lenz law. Okay, we have a Lenz law, and I have told you there is a no proof of a law. We have to basically know the law. Okay, so what is the first? So from here only we got the definition of Faraday's law. What is Faraday's law? Faraday's law simply state that the EMF induced is equal to minus d phi by dt. Okay, that is changing, rate of change of magnetic flux is equal to the EMF induced. And remember this minus sign is due to Lenz law. Okay, due to Lenz law. Now what is that reason for that minus sign, I will tell you later, but for you now the magnitude is very important. If we are talking about magnitude, then the magnitude is very important. For magnitude point of view, you can say my EMF induced is equal to d phi by dt. That is my magnitude, correct? That is the magnitude. Okay, so that is the magnitude you have to remember. The rate of change of magnetic flux is equal to EMF induced. Rate of change of magnetic flux is equal to EMF induced. That is a statement which is given by the Faradays. Now the next thing is that, okay, we know about the Faradays, we know about that what is the law of the Faradays, but now the thing is that, okay, suppose we will calculate the magnitude of the EMF, because we know how to calculate the magnetic flux, correct? We know how to calculate the magnetic flux. Okay, for calculating the EMF we have to just differentiate it with respect to the time and we can calculate the EMF. Now the second question is how to calculate the direction. For that we have something called as a Lenz law. Now what is the Lenz law? Let us see. Lenz law states that in the next session we will do a lot of examples and illustrations on this. Just note down this Lenz law. What is the Lenz law basically? See, Lenz law state that the current will induced, I induced in such a way that it oppose the, okay, I is induced in such a way that it oppose the reason by which it is generated, correct? Any doubt till here? Okay, so what is the basically the rule? Okay, definition no one will ask you. Let us see the rule. So suppose I have a magnetic field here. Okay, and suppose this is my circular disc or something and the magnetic field is changing in this. B is increasing. Suppose if B will increase, then flux will what will happen to the flux? Flux is BA cos theta, correct? B is increasing, so flux will increase. So flux is changing with time, correct or not? Yes, it is changing. Flux is increasing. So what is the reason for the Lenz? What is the reason for the current induced? That is the increase in magnetic field. So it will try to induce the current in such a way that it will oppose that increase in magnetic field. Okay, basically here the magnetic field is increasing. Due to this increase in magnetic field, the flux is increasing and the EMF is getting induced. So what is the reason? The reason is increase in magnetic field. So it will try to, according to the Lenz law, it will try to induce the currents in such a way that it oppose the reason by which it is generated. So what is the reason here? Increasing in magnetic field. So it will try to induce a current in such a way that it will decrease the magnetic field. So the magnetic field is increasing, but this magnetic field is increasing inside. If I want to decrease the magnetic field, I have to keep the magnetic field outside, correct? So I will keep the magnetic field outside and curl your finger. So what is the direction I am getting? I am getting this direction, correct? So this is my I induced. I hope you are getting the point. That is a very simple method. First you have to see the reason by which it is happening, and once you got the reason, just what you have to do, you have to simply do the opposite of whatever the thing is given. Clear? That is the thing you have to do. Let us take some example, then you will understand. Suppose it is a wire of infinite long wire, correct? Infinite long wire, okay, and suppose I have a this square, and suppose it is moving with a velocity of v, correct? My question is very simple. What is the suppose the current is I, what is the current induced, what is the direction of current induced? You have to find the I direction. You have to tell me the direction. I'm not asking the magnitude, first you tell me the direction. See, if it is moving from in this direction, whether the magnetic flux will be increase or decrease, first you try to understand. See, if you move from here to here, obviously my magnetic field is decreasing, correct? Okay, if my magnetic field is decreasing, my flux will decrease. So yeah, the current will induce because there is a change in flux, but the flux is decreasing. Why the flux is decreasing? Because magnetic field is decreasing. So what it will try to do, it will try to induce a current in such a way the magnetic field will increase, because just opposite what is happening. So and the magnetic field is decreasing in which direction? It is inside direction, because due to this wire the magnetic field will be inside only, correct? So the magnetic field is inside, we know that. So it will try to induce a current in such a way that it will increase this magnetic field, and for that the current induced will be in this direction, correct? So the current induced will be in this direction. So this is how the current will induced. Clear? We will do some more example in the next session. I hope you have understand the concept what is Faraday's law and what is Lenz law, and I hope you have enjoyed this session. In the next session we are going to do a lot of examples on this. Till then, if you have liked this session and if you have enjoyed it, please like it, share it and subscribe it. Have a nice day. Thank you.